Lesson 24, it's calculating probabilities, talking about mutually exclusive, conditional, and unions. So let's talk about mutually exclusive. All right, you got two events. So let's talk about like event A. You have rolling a dice and landing on 3. Okay. Then let's talk about like event B, rolling a dice and landing on a 4. You cannot roll the die and land on 3 and 4 at the same time, right? So those would be called mutually exclusive. Now, let's talk about what would not be. Rolling a die and getting a 3, that would be your first event. The second event would be rolling a die and getting an odd. Do you see how, right? It's because 3 can also be getting a 3 and being odd. Those cannot happen at the same time, okay? How are you with the conditional probability? You would know that it's conditional when it would say given that, or it would say if. So whenever they do that and they talk about that in the question or in the scenario, then you would know that they're going to tell you, that will tell you as far as how to calculate the probability of the second thing happening. You already know about independent. Venn diagrams are good visual aids. Typically, they're only usually used with 2 events. I have seen them used with 3, but typically they're usually with those, with just 2. Sorry, hiccups. Things happening. Okay. Now, for them to be mutually exclusive, would you agree that this Venn diagram is portraying that?
Yes.
Why would they not intersect? Because they're not going to have anything in common, right? So they cannot overlap because they cannot occur at the same time, with A and B acting as events. Okay. How would you... Okay, so A, it's saying on example 2 that event A is saying the student chosen at random in the stat class. So event A is saying that they scored a C or higher on their last test. For event B, the student scored a D on their last test. They gave you the probabilities. So explain why events A and B are mutually exclusive.
So they don't affect each other. They have no effect on one another.
Right, so like a randomly student cannot score a C or higher and a D at the same time on the test, right? Let me scooch this up for you.
Wait, which one's the opposite of mutually exclusive? The conditional?
Yeah, where they are happening at the same time.
So if that says a student showed the score to D or higher on their test, they wouldn't be conditional?
Right, then they would not be mutually exclusive.
Yeah, but why does it say at the same time? Like,
Oh, this is what they use in the...
I don't get this stuff. Because it's saying student A and student B are 2 different people.
It's just the same student.
They're talking about different events happening, so they're wanting to say, okay, well, event A and event B, do they have anything to do with each other? No, they don't. Okay? That's like rolling the die and getting, like a 3 and an odd. Well, they do, right? Because the 3 is also odd. But on this one, either the student scored C or higher, or the other student scored a D. You can't score a C and a D at the same event, or on the same test, I should say. Okay. And I added on this one, it says at the same time, and I said on the same test is what I put, because that's what it's talking about on their last test. All right. How would you describe in words the probability of event A or B occurring? Here's your notation. So here's A or B, and then here is the union is what or means. How would you write that?
A or B.
Mm-hmm. Or? So is the probability of event A occurring or
Probability.
event B occurring or
Second A, right?
both occurring, right?
How are they both occur? They can't both occur. We just said they can't both occur, so why are we saying they can't?
It says or.
Could. It's or. It's a
We just
possibility.
said they can't.
No, you said
You
A
just said
or
before
B,
that.
Oh, you're saying
and then
or
you said
both.
both.
This is just talking about the or.
Isn't it related to the question?
This is just describing.
This makes sense.
Is this related to mutually exclusive things or just general?
I mean, it's related to the mutually exclusive,
Okay. We said
You just said it can't occur. It says-
event A or event
but
B.
it's talking about as far as, you know, just in general on the union and the or part of it.
I'll be honest with you, that still makes no sense.
Hold on, we'll talk about it. Hold on. Hold on. So if C is the event that the student failed the last test, what's the probability of event C?
Event
So what would you consider failing?
1 minus A plus B, right?
So is D considered failing or C?
In my book it is, but
And college.
an F,
D is
right?
Yeah.
So what would be,
C minus A minus B.
what was the probability of getting a C or higher? Was it 0.68? Okay, what's the probability of a D? 0.09. Okay, so
0.2.
there's a couple ways to go about this.
You add them and one that's yeah, so when you add them and subtract that.
You could. Yep. So the 0.68 and 0.09 could add them together. And then you could do 1 minus that, right? Okay.
How do you have a 68%?
Where are you getting these numbers from?
Look up
Oh, where?
above A, like example A.
From where?
Yeah, it's up top.
What does this fucking mean? Doesn't mean anything.
What are you talking about?
He doesn't know where the P is at.
I don't understand what these numbers mean.
That's the probability.
Up top is the probability. It says that because the event A is talking about a student chosen scored a C or higher on their last test. So the probability of that was 68%, 0.68.
How is it possible there's a high percent of somebody failing and somebody getting a B?
It's based on his individual grade, probably. That's what the average is.
Yeah, it's all. Yeah, it's just based
If
off
he usually
of.
passes, then it's going to go
Yeah.
on to that.
So it was a 9% of a D, 68 for a C. So what was the probability of failing, of getting an F? 23.23? Okay.
He makes a C or higher on 68%.
Is that how we're gonna write it, or?
Always in decimal,
Oh,
yeah.
decimal.
Mhm.
Yeah, but how can he have
Yeah.
a 5% scoring than being here, though?
Because on average, he passes 68%.
Why are you adding?
By that, this plus this, plus something, that equals 1 and failing on the bracket.
Because we're adding both of the A, B, and C together with the D. Because the 68% is including, a C or higher, right?
I got
So-
it now.
Okay. All right, calculating conditional probabilities. This is when you want to know the probability that event A will occur when event B has already occurred. Okay? That's called conditional probability. Here's the notation, and this line right here is what means given that. So when you see that, you want to find the probability of A given that B has already occurred. I like that it's also in words up here. So that's at the very bottom of the page we just did. Okay. There are two context clues that can let you know the probability is conditional. What are the two I told you? Given that and if. LaBelle can definitely read. Signify the probability is conditional. So what comes after those clues is your condition of what must happen first.
That's not you. What is that? Is that like intersection? What's that called again?
That's intersection, yeah. All right. So how would we write this in words? That's what the next piece is saying.
P of A intersects P of B divided by P of B. Cancel out the P of B.
So the probability of event A,
Given B.
given that event B has already occurred, right?
Can I just cancel out the P of B?
No, that's not how it works. It's division.
This is the probability of event A, put event A right here, given that event B has already occurred.
Do you have to use like event, or can you just?
Event. Okay. So let's just talk about some different scenarios of things happening, not necessarily conditional, but let's just talk about different things that you're going to, how one event can affect another. So let's say the probability of getting an ace from a deck of cards, okay, from a standard deck of cards. How many aces do I have?
4.
I got 4 out of 52, right? Okay. So, but what if I decide I keep the ace that I get, okay? And I want to know now what's the probability of getting a king? 4 out of 51. So did the event of me getting that ace affect the event of getting the king? It did. If I keep it, right? Right? So if I keep that ace, if I keep that, that's changing my deck of cards, right? That's changing my sample space. So you got to think about that, and you'll see clues as far as where it says with replacement. That means I put my ace back in the deck, or without. That means I kept it. Okay, so you got to think about those clues about how it's affecting the sample space, and we'll get into that in just a second. All right. Multiplication rule. This is your union, totally lied, intersection. Whenever you see intersection, it means to multiply, or you see the word and. I want this and that. And that should say, do you see how it has the P right here? That should actually be A right there, and the P should be on the outside because it's the probability of A and B, the intersection of them. So that's wrong. All right, let's see if you can fill that out in the bottom part without me showing you. From what you've seen, if you need to come up here and look, you're more than welcome to come up here and look.
So the suits go from ace to 10?
Yeah, I always treat ace as a high card, but it also can be treated as low card. But as far as probability goes, there's no value to it unless you're in poker. And I always put it as the ace, king, queen. That's just how I've always done it.
Usually in card games, though, I use it at the high one. I've already decided not to.
Are they cloves or clovers?
Clubs.
Clubs.
Club.
I was like, that's not a club.
Definitely club.
That's
Clubs.
what my 5-year-old sister
Club,
finds.
spade, diamond.
I thought it was cloves.
Crap.
You guys are funny.
You'd be wrong.
I probably knew it was cloves.
Would an ace count as a fixed?
I did look at it.
No.
No.
It literally has a face on it. So your kings, your queens, your jacks. Yep.
You don't count aces as face cards?
No.
Really?
Right.
Really?
I would, but not in probability. It is not. Yeah.
Is it 10 face card?
No. Literally has
Why
faces.
would it- oh
Why
my
would
God.
a 10 be?
They have the same number.
Wait. Pause.
Face
What is
cards,
it?
I would not.
10,
Yeah,
10,
there's
10, 10.
No.
No.
10, 11, 12,
You're talking
13.
about
Exactly.
blackjack.
Yeah, you're talking about blackjack.
Yeah, blackjack
No.
is the
What
biggest
if
game.
I use a few
We're talking
cards? The
probability.
kings were 3 cards, the queen is 2, jack is 1.
Wait, no, these are
Aces are not their own suit.
That's talking about Egyptian
They're part of
Ace
it.
of hearts, ace of diamonds.
Egyptian wrestling, we get to put down 3 cards.
You're
You're
like
so
12
good.
years old.
Because there's
Bro,
4 rows if you look
I'm
right
better
there.
than you. I'll beat you at poker. I'll beat you at anything.
Don't beat me at blackjack.
Wait, is ace
You know
of
what
diamonds?
No. Right. Literally the cards that have the faces on it. Yes.
Are you sure about that?
Okay.
Okay.
Always know too, because face cards are a very common probability. So always know how many total face cards you got. You know you got 12 face cards.
I learned this in algebra, and then I just couldn't forget it.
Yeah.
Like I knew this,
Yeah.
and now I'm just like, how many?
I really only know this from playing cards. Otherwise,
Okay. All right. So we talked about Venn diagrams, and we're going to do some at the bottom. But we also have like another way to set up as far as your sample space goes and kind of keep your work organized is making a two-way table of the sample space. Okay. So I don't know if this is, oh, it is filled out. Okay. So on the top row, do you see, you can do, well, I'll just show you. Does this make sense that my total is 52, right? Because of how many cards I have. We've got diamonds, and we've got not a diamond. That's what my events are talking about here. So getting dealt a face card, getting dealt a diamond. The F is representing your face card, and then F prime, or F not, that is your not a face card. So we already know how many diamonds we have that are face cards. That's your king, queen, jack. So there's 3. How many total face cards we have? We know there's 12. So the ones that are not diamonds are the other 9. Always make sure that you always have your, of course you would set up your probability in fraction form, but then your final answer should be in decimals, probably to the 4th place value, rounding.
You think Tyler's gonna draw the audience?
All right. So how do we get 3 out of 52 for the probability of a face card and diamond?
3 cards in the entire deck that's
Yeah, we're looking at diamond. Here's our diamond row or column. Here's our face card row, and the ones that combine, right? My intersection that's included in both is 3. So 3 out of the total deck, 52. What is that as a decimal? Okay. So 0.0577?
Yeah.
Okay. All right. All right. So on C it says explain why the probability of getting a face card or diamond is not equal to getting the probability of a face card plus the probability of a diamond.
Plus represents. No, you said and was multiple.
Yeah. So I'm gonna say it again. I'm trying not to say the words. The probability of a face card or diamond is not equal to the probability of a face card or the probability of a diamond.
Oh,
because you can get a face card that's not a diamond. And you can get like
they're mutually exclusive. No. The Pretty much.
Yeah, probability
I
of
mean, they
getting
can
a
happen
face
at the same
card.
time, but like, they don't have to.
Okay, so what's my probability of getting a face card? What would that be?
52.
12 out of 52, okay? What's the probability of a diamond?
13.
13 out of 52. And what does that give me?
25 out of 52.
Okay, so what do we see happening here? I call it double dipping, but what's going on? With the face cards and the diamond. There are face cards that are diamonds, right? So 3 of those face cards that are diamonds have been counted in that probability twice. Okay? So what do you think we would have to do with that? We would have to get rid of it, yeah. So yeah, we'd get the 25 over 52, but then we would take out the face cards and the diamonds, or the 3 face cards that are diamonds. I actually did my calculations up here of what it would be correctly. So this is what you would call your general rule for addition, and that's what it's leading up to, is your the or part or the union part.
If the odds of F were like 0, then this would apply, right?
Okay, so let's calculate on D. Now we're calculating, I did mine up here, but D is actually calculating it true. So how would we set that up? It says we're applying, so we know that we want to know the probability of event A or event B. So in this case, face cards or diamonds, right? How would we label that out? Probability of the face cards plus the probability of the diamonds, but then we got to throw away what they have in common. So subtract the probability of the face cards and diamonds.
9 out of 52 plus 10 out of 52.
Say that again.
9 out of 52 plus 10 out of 52, right?
22 out of 52. We already calculated what the probability of a face card and a diamond is. And that's what we have to throw out, because that's what they have in common. Mm-hmm. Is that what you got? Yep, 0.4231, yep.
Can you write it as decimal?
Always put it as a decimal once you get your fractions done, and round to the 4th place value.
That we calculated the probability earlier of 3 out of 52, and then I just subtracted it.
Yeah, that's all you're doing. That's exactly what you're doing. All right, how would we represent the Venn diagrams, let's say for the one on the left, for the intersection? What would those look like?
What's the upside down union?
Intersection. If it's a U shape, that's union. That's how I memorize it. Union for the U one, and then intersection. So intersection is where they overlap, right? And then the one on the right, we can do the union.
Is 40 over 52 just 12 over 2 times 13 over 52?
Not times, plus.
Is 3 over 52? How much?
What are you talking about?
I'm talking about 3 over 52. That's 12 over 52 times 13 over 52, right?
So does it make sense that when we are on the union piece of what's happening, that this whole circle is representing event A. This whole circle is representing event B. So this is where it's overlapping. That's why we take that out, because it's counting it twice. So that's why we subtract the intersection piece when we're doing or year. Okay? How's that? Okay?
Honestly, I'm probably in the
Huh?
Why the color thing in the intersection?
Because that whole circle, this whole circle right here, is A. Right? That is A. And then this one is B. So I have the probability of A. Then I also have, so I'm adding the probability of B. But then notice this is what's being counted twice. So in my OR, I have to subtract it. Because that's how it's being counted.
Since there are two of those.
Yeah, because in each probability of A and B, I'm counting them within those own individual probabilities. All right? So independent or dependent? You've got to always be able to, even when you know that two events are independent, you will have to show it mathematically. Okay? All right, so if we are certain that two events are independent, we can calculate the probability both events occur with the following equation. So this being the intersection, that the probability of A and the probability of B, so that's why we're multiplying them. So this is how you would figure out how to mathematically prove as far as if two are independent. So you see here, I'd have to say, okay, well this probability of my A has to equal the probability of A here. In other words, you see how it has given that B? And on this one it says, and the probability of B has to also equal, or given that A also has to equal the probability of B itself. We're going to do some of those, don't worry. That's just your formula. We're going to do it on the next example. Okay?
If you are a 10th grader and in the midst of time focus class, please report to the cafeteria at this time when you're elected.
All right, let's set up our two-way table. What do we got here? 82%. And we're just going to keep this table easy. We're just going to have our total. We'll just have it out of 100 to represent percentage. All right, so when we put the numbers in there, we know it's representing percent. We got Facebook profile, so 82% of students' Facebook profile, 89% Instagram, and 71 use both. So put your Instagram on your columns and put your Facebooks on your rows. Okay? Give you a second. Just put your Instagram on the columns and then your Facebook on the rows. So how are we gonna, what's the other part of Instagram? What's gonna be beside it? Not Instagram. So I prime, right? All right, you have it all filled in?
Which one goes on the roads?
Facebook, Instagram. It doesn't matter which way you set it up. It's just if you want to look with, you know, when you see what I have, it'd just be.
No, Facebook. Instagram.
These are roads. She said Instagram.
Yeah.
I said Facebook,
This is
Instagram.
He's saying, as you said, Facebook goes across.
Yes,
Yeah.
yes.
Is that how it's supposed to be?
Yes.
That was what I mean. Just if you want to match up.
Facebook here.
Just show us. It's not that hard.
Oh my gosh.
That's cute,
Oh my gosh.
Okay.
Wait. Oh, shoot. I did it backwards.
Facebook is rows.
Yeah.
It doesn't
it's
matter.
rows.
I guess when you say column, I was thinking,
To column is
Yeah.
right
But
up
not-
and down.
You label the rows.
So when I
Instagram is this way.
You like that?
that's Facebook.
Yeah.
No, but when you say
Column.
This guy goes, yeah.
So this one you should have gotten by calculation, this one by calculation, this one, and then this one. Okay? I can leave this up so you don't have to keep flipping back and forth so we can answer the questions on the next page, all right? Okay, so how would we set up a Venn diagram for this? By looking at what they have. We're going to have one circle is going to represent Instagram, one circle is going to represent Facebook, right? So what's in the overlapping piece?
71.
71, okay. So go ahead and fill that out. Ooh. Okay, so I have Instagram and I have Facebook. So what number would I have here for my Instagram?
18.
18. And why do I put an 18 here and not 89?
We already included the people that use
Right. So this whole thing, right? This 18 is what has nothing to do with Facebook.
Yeah.
Right? Very good. That's just a common mistake that students make. And then out here we would put 11. Good. Would we have anything out here? In this case we don't. If we did, I mean we would put whatever, but there's nothing that's not in both of them. Right? Okay. So what's the probability of a Facebook user?
82%.
82. Okay? So my total Facebook is 82. So 82 over 100, and we know that's what, 0.82? I'm leaving this up here so you don't have to keep flipping. What's the probability of Instagram? Well, I'm going to my Instagram. My total Instagram is 89, right? So 89 out of 100. So 0.89. How do I read that on E? Facebook and Instagram. So Facebook is here. Instagram is here. They both intersect at 71, right? So 71 over 100 is 0.71.
Wouldn't it be easier to do all this first?
I mean, you could do either or. I mean, it's all from this. It's all the same. All right, well, how would you set up Facebook or Instagram?
118 plus 111. Oh, wait, no, it's not a thing, you're right. Oh, wait. It's
I know what we're doing it. I just can't explain it.
0.82 plus 0.89 minus 0.71.
Yeah, that's not doing it. That's not going, that's a negative, I know.
But it's saying just Facebook or just Facebook.
How's that negative number?
Nope, it's saying probability of Facebook or Instagram.
0.82 plus 0.89 minus 0.71.
It's negative.
That's the formula right here. How's that
Yeah,
negative?
it is.
How you can get a negative?
Okay, now
How is that a negative?
let Caleb take the wheel on this one. He's right.
You said point?
Oh my God.
8.
Well, what's our event stuff already
Taking the
reflecting?
individual ones.
We're talking about Instagram and Facebook, right?
I took the individual ones out.
So we know that all of it's gonna be 100%. Cause it's either gonna be Facebook or Instagram, right? It's 100, it's one.
Yeah,
my
because
God.
if you do it, you get one.
Caleb, take the wheel.
I was like, I thought it was 100, and then I was
Yeah.
like,
Caleb, we're confused.
Yeah.
Start talking.
So you got the 18, right? The 71, and you got the 11. I mean, all of it. All of them. Facebook or Instagram. It's all of them, right? So it's 100%. 100 over 100. One.
seems way too easy.
Okay, now we're going to get into some conditionals. All right? We're going to get into
This
conditionals.
is the one I told you guys. I was right.
We said you were right.
Caleb, everyone agreed with
We
you.
all agreed. We were literally.
We are on
singing
G
your
now.
praises for
Caleb, we're on G. Okay, so now we're getting to conditional. So it says a probability of Facebook given Instagram. Okay, given that Instagram. So how do I set up my formula?
That's a good question.
Look at the Venn diagram and tell me what there's on Instagram.
So we want
Oh, wait.
Facebook given that Instagram. So I know. Huh?
0.89 equals 0.82. It's true. Done.
What am I doing? Facebook given that Instagram. Okay. So you should have the intersection of both of them. So both divided by Instagram.
Oh, that's disgusting.
Well, haven't we done both already?
I don't remember.
Okay. It's right above it. Yeah. So you have 71 over 100 all over. And then what's my Instagram? 89. What does that become? 0.7978.
It seems I have not my calculator. Not me.
No, I haven't used it in like a few weeks, but
Yeah, it's been a while since you've had it out. How would we rearrange it for H? Because all I did was flip flop it.
So it's the same except just the probability of F on the one.
89 over 6.
F.
Yeah.
We do 89 over 70.
I put down UI divided by F.
So you have, yeah, so the probability, Instagram and Facebook, but then we're dividing by the probability of Facebook. So that's,
0.71 over 82.
yep. Yeah, 82. I got 0.8659. So what you got? Okay.
No, they're not independent. Because G and H don't equal each other.
Right. Yeah, we did the work, right, on, to talk about as far as if they're independent or not.
Way too.
So it's exactly what I is saying, that these two, you see how we switch these? These two have got to equal if they're independent, and these are not independent.
Soon. Soon. Soon I will be considered.
So you would have,
I just looked over and you were like,
Good, thank you.
I thought it was gonna be empty. It sounds like there's nothing in there. It is. There's no. There's gummy chocolate. I was like, wow.
and this one would have to equal the probability of Instagram. And what is that, 89? So both of these must be equal, and they're not. So they're not dependent. I'm sorry, independent. Okay.
Wait.
Yeah.
Why can't you just say? Why can't you just say G and F, G and H don't equal each other? Wouldn't that be the same thing as that?
Well, no, because the probability of what I have there, the probability of Facebook given that Instagram has to equal the probability of Facebook. Yeah, you did the first part of it, right? But you have to make sure that it equals the individual event itself.
So it is or it isn't?
It's not. Wait, it is.
Can you just show what?
I did. I'm showing you right here. So the probability, isn't that what G was? Right, the probability of Facebook given that Instagram. Well, this has to equal the probability of Facebook. Okay? So what was that? Well, the probability of Facebook given that Instagram, we already calculated that in G. That's what this is saying. But it has to equal the probability of Facebook only. What was 79 over? So we're just going to say 0.80. That is not equal to 0.82. So this is one part of it right here. The other part is this one. So now we flip-flop them. I think this was what, H? Yeah, H. But now I have the probability of Instagram given that Facebook. It has to equal the probability of Instagram. So 71 over 82 is what? I'm just going to say 0.87. That is not 0.89. So these are the two pieces on proving if they're independent or not.
So if they equal or independent, not equal.
Right, right. Do you see how you have to flip-flop them? Okay.
And you have to have both.
Yes, both has to be true. So we did this piece on each one in G and H, right? Because we flipped them based on the formula. But then they have to equal, depending on what comes first, right? That's the individual event itself that it has to equal. But think about that,
Yeah.
right? Because remember, this is a conditional thing, so we're just proving are they independent or not. Because what this means is that given that Facebook, because Facebook has already happened, that means it had no impact on that, which would make it independent, but they're not independent. All right. How you doing?
I like this better than the other graphic.
I'm sorry.
I kind of get it.
It makes.
It really takes practice. It really does. Really does.
So say long sentences for this, like you can literally
No.
show the math.
Yeah. Yeah.
Oh, right now.
Okay, here we go. Now we've got the probability that a person has a particular virus is 1 out of 250. If they have there's if they have the virus, the probability they test positive for the virus is 0.9. If they do not have the virus, the probability they test positive for the virus is 0.15. Okay? So, which has happened first? Well, if they have the virus or if they don't, right? Okay, so that's your first thing. And remember, you can, I just, V and V prime for not having the virus, and then the virus. And then the next thing was testing positive or negative, right? That was the second thing.
We're never gonna be able to look at the whole virus.
I know.
Potato right now.
Okay, now we're drawing a tree diagram. How would we start this out?
If I meet Justin Bieber in July, I will fight every single person who looks at me ever again.
So we have our little, dude here. What are we calculating?
Well, what? Yeah, bro, I should have probably done it.
Virus.
Oh my god.
All right, so what's the
Big boo.
probability of that?
Probability of a virus is
1 out of 250, okay? So I know it's 1 out of 250. What is that in decimal form? 0.004. So this is virus. This would be not having the virus. So what would that probability be? If this is 0.004, this would be what? 0.996. The two of you are about to leave my room. All right, what's the next condition? The next event would be what? Yep, testing positive. So we can have, if they have the virus, be positive or negative. What was the percentage for positive? 0.9. And then not would be 0.10, right? So I looked at this as testing positive given that they had the virus. This one I saw as probability of negative given that they had the virus. Okay. What about the next piece?
virus, positive, negative, and then 0.15 positive.
So the test positive was what? 0.15. And then negative would be 0.85. So this was probability of positive, given that they didn't have the virus. Probability of negative, they tested negative, they didn't have the virus. So the yellow is your second event. That is what's conditional upon the first event happening, which is in blue. All right, so the probability of the virus and being positive, so the probability of the virus and being positive .0036. Okay? Would you agree? Okay. What's the next one? Positive virus and testing negative. So that's this one. So I got virus, which is 0.004, and negative, which is 0.10. Now I'm going on the next one. So not what?
Shouldn't that have 3 zeros instead of 2?
Oh, yep. That's what I get.
Also, on the test, do we have to write those little P, like,
Yes.
plus and V?
Whatever notation is required. So I have not.
May I have your attention, please? If you are a 10th grader and you have Miss Kenny for your focus teacher,
And
please make your
positive.
way to the cafeteria at this time to select your elective. Thank you.
And then 0.85. Okay. So how do we answer question A? Given that a person tests positive for this virus, what is the probability they have the virus? So we have, I'll write it over here. So the probability that they have the virus, given that, I'm sorry, that they test positive, right? Given that they test positive, what's the probability that they have the virus? So the probability of they have the virus, given that they test positive. How do I do that? So the probability of the virus and they're positive well, didn't we do this one right here, right? So we already did the virus and being positive. 0.0036. And then what's the probability of testing positive? Wasn't there 2 ways? Test positive? Okay, so we have 0.0036 plus point what? 1. Yeah, we have these 2, right? So we got to add those together in the denominator. I don't know what that is. I just wrote it out. I got 0.0235 as my total. Okay. So we had this one testing positive and this one.
It's a lot of stuff on this lesson.
All right, last one. So given that a person does not have the virus, what's the probability they test positive?
So not 0.15? Said that in the very beginning. If they do not have the virus, probability of test positive for the virus is 0.15.
Okay.
Now you gotta make it complicated.
Can I erase this bottom part? Because I don't know where my screen actually ends here.
Next time, I'll bring Adderall for class. You know, we'll just
All right.
give all this stuff.
All right, so given that they do not have the virus, what's the probability they test positive?
See, why are you writing it in that order? That's when you put the positive.
Given that, okay, look at the question. Given that, isn't this my given that? Right?
Yeah.
Okay, so what's given that? They do not have the virus.
Oh, okay.
See that? And then what are we wanting to know the probability of? They test positive. See that? Okay. That's really important to know, I think. All right, so the probability of positive and not having the virus divided by the probability of not having the virus. I mean, yeah, we've already calculated this, but this is like, if you didn't see it, how you could still get it. And then so it's 0.15.
Yeah.